Let us solve a question on three-firm cournot Nash equilibrium. The question is, an industry has three firms, there is firm 1, firm 2 and firm 3. In cournot competition, they have no fixed costs and their constant marginal costs are respectively marginal cost of firm 1 is 9 upon 30, marginal cost of firm 2 is 10 upon 30, and similarly C3 denotes the marginal cost of firm 3, which is 11 upon 30. They face an industry demand function that is being shown by P is equal to 1 minus Q, where P is the market price and Q is the industry output, that is the sum of outputs of three firms. Suppose that Q subscript C is the industry output under Cournot Nash equilibrium. We need to find out the value of Q subscript inverse. Q subscript C, its inverse, we need to find out the value. Okay, since it is a Cournot model, firms will compete in terms of prices. Okay, let us first write our demand function. So our demand function will be equal to P will be equal to 1 minus this Q denotes the output of three firms. So we can write it in this fashion. That means in place of Q I can write Q1 plus Q2 plus Q3. Okay, so here in place of Q, if I write this, we have to subtract this, then it becomes Q1 minus Q2 minus Q3. Okay, this is our inverse demand function. Now we take three firms one by one. First we will find out the marginal revenue of firm 1 and we will equate it with its marginal cost. Then we will take marginal revenue of firm 2 and equate it with its marginal cost, and lastly the marginal revenue of firm 3 and equate with its marginal cost. Okay, let's take firm 1 in consideration first. So to find marginal revenue, we need to find out the total revenue, and we know total revenue is simply equal to P into output, that is Q1. So this is our P, that is 1 minus Q1 minus Q2 minus Q3. To this we multiply Q1. Okay, so our total revenue will be equal to Q1 minus Q1 square minus Q1 Q2 minus Q1 Q3. Okay, now what is marginal revenue? Marginal revenue of firm 1, marginal revenue of firm 1 will be equal to simply differentiating this with respect to Q1. Okay, let's denote it by TR prime. Okay, so if I take the partial derivative of this function with respect to Q1, so derivative of Q1 will be 1, derivative of Q1 square will be 2Q1, derivative of Q1 in this term is 1, so we are left with Q2, and here derivative of Q1 again is 1, so we are left with Q3. Okay, that means this is our marginal revenue. Now we equate marginal revenue with marginal cost. That means marginal revenue of firm 1 should be equal to the marginal cost of firm 1. Marginal revenue is being given by this very function, that is, and let me write it here, I don't have the space. So we have 1 minus 2 Q1 minus Q2 minus Q3. We equate it with the marginal cost of firm 1 is 9 upon 30, and we can write it 1 upon 10. Okay, if I transpose these terms here, they will become positive, and if I transpose 1 upon 10 here, it will become negative. So we have this stuff, twice Q1 plus Q2 plus Q3. So this gives us the act. So this comes out to be, so we have here 3 3s are 9, 3 10s are 30. Let me see if I have done any mistake here. So we have 3 3s are 9, 3 10s are 30. So it is actually 3 upon 30. Okay, 3 upon 10. So we have 3 upon 10. Sorry for this mistake. Now 10 minus 3 comes out to be 7 upon 10. Should be equal to twice Q1 plus Q2 plus Q3. Okay. So what will we get? We will get twice Q1 plus Q2 plus Q3 will be equal to 7 upon 10. Okay, this what we call the reaction function of firm 1. If we solve it for Q1, I don't need to solve it for firm 1. We will get the reaction function of firm 1. That means by reaction function what we mean, output level decided by firm 1 when firm 2 and 3 have decided some level of output to be produced. Okay, we don't need to find out the reaction function here. Okay, let us say this is our one equation. After that, let's take firm 2 into the consideration. Okay, in firm 2 you will see I don't have the space here, so let me try for firm 2 also to make sense for you people. So total revenue for firm 2 will be equal to P into Q2. Okay, so our P is this function, that is let me write it here, 1 minus Q1 minus Q2 minus Q3. To this we multiply Q2, so this will become Q2 minus Q1 Q2 minus Q2 square minus Q2 Q3. Okay, this is total revenue. What is marginal revenue? Marginal revenue for firm 2 will be, if we take the partial derivative of this function with respect to Q2, so we will get 1 minus Q1 minus twice Q2 minus Q3. Okay, again we equate it with the marginal cost. That means marginal revenue 1 should be equal to the marginal cost of firm 1. Marginal revenue is this function. Okay, so let's rewrite it here. Okay, we have 1 minus Q1 minus 2 Q2 minus Q3. We equate it with its marginal cost. 10 upon 30, we can write it as 1 upon 3. Transposing these terms, they will become positive. Transposing this term, it will get subtracted with this 1. So we will get Q1 plus twice Q2 plus Q3. So this comes out to be 2 upon 3 will be equal to Q1 plus twice Q2 plus Q3. Okay, so we will get another equation, that is Q1 plus Q2 plus, sorry, we have Q1 plus twice Q2. So we have Q1 plus twice Q2 plus Q3 is equal to 2 upon 3. Symmetrically, if we solve for Q3, okay, if I solve for Q3, what will I get? Simple thing. So we have this very stuff. I will left that very thing for you as an exercise. That means for firm 3, what will we get? For firm 3, when we write total revenue of firm 3 will be equal to P into Q3. Okay, then you will find out marginal revenue and equate with marginal cost. Okay, that means we will get this kind of equation, that is Q1 plus twice, sorry, Q1 plus Q2, Q2 plus twice Q3. Okay, we have 1 minus 11 upon 30. So this comes out to be 3 divided by 30. So you will get this very equation, 19 divided by 30, when you solve for firm Q3. Now we have 3 equations with 3 unknowns. We need to find out that very stuff. We will use the Cramer's rule here in solving this. I don't know whether there is any shortcut to solve this question. Okay, and I am really surprised why such a long numerical question has been asked in the exam. So we have 3 equations with 3 unknowns. That is, we have twice Q1 plus Q2 plus Q3 is equal to 7 upon 10. Then we have this for firm 2, we have Q1 plus twice Q2 plus Q3 is equal to 2 upon 3. And for third, we have Q1 plus Q2 plus twice Q3 is equal to 19 upon 30. Okay, three equations with three unknowns. We use Cramer's rule here in solving this. We write it in matrix form in such a manner that means A times X is equal to B, where A denotes the coefficient matrix, and let me write it here. So what will be the coefficient matrix? That means the coefficient of Q1, Q2 and Q3. So the coefficient of Q1 is here 2, here 1 and 1. So I can write 2, 1, 1. Then we have 1, 2, 1. Then we have 1, 1, 2. X denotes the solution vector that we want to find. In place of X, that means we want to find the value of Q1, Q2 and Q3 should be equal to vector of constant terms here. That is, we have 7 upon 10, 2 upon 3, 19 upon 30. Okay, now first we need to find out the determinant of this very let me see if I have any space here. First I need to find out the determinant of this very matrix. Okay, how do we find out the determinant? And I guess I should rub this out. Now we have nothing to do with this stuff. Okay, and let me rub this out, then it will make sense. So first step is we find out the determinant of this matrix. That means A will be equal to, how do we find a determinant? You know it pretty well. The determinant of this, so this denotes A, this is our A, this is our X and all the stuff. So determinant is simply found out by, we write the first term for, okay, to this we multiply, we mentally delete this row and this column and take determinant of remaining elements. That means 2 2s are 4 minus 1, so we will get 4 minus 1. Then we write minus, and it is from the formula minus, and we write the next term which is 1, this term 1. To this we multiply what? We mentally delete the row and the column in which this 1 appears and take the determinant of the remaining elements. That means we multiply these two elements. 2 1s are 2 minus 1 1s are 1. Then we write plus. So first is plus, then minus, then plus. We write plus 1, this one, and mentally delete the row and the column in which it appears and take determinant of the remaining elements. So we have 1 1s are 1 minus 1 2s are 2. Solving this, okay, you will get determinant equal to 4. Okay, I don't have time, space and energy here to do all the stuff here. Okay, now to find the value of Q1, the optimal quantity of Q1, and let us write here to find the value of Q1, what will we do? I will not write here, I don't have the luxury of so much space. To find the value of Q1, we form new matrix, and let me write it here. We form a new matrix, let us denote it by A1, such that, again, to find the value of Q1, we form new matrix such that we replace first column of this matrix with the vector of constant terms. Okay, so in place of 2 1 1, we write the vector of constant terms, that is 7 upon 10, 2 upon 3 and 19 upon 30, and other stuff remains same, that is 1 2 1. Then we have 1 1 2. Okay, let me repeat it again. To find the value of Q1, we replace first column of this coefficient matrix with the vector of constant terms. Okay, and take determinant of this new matrix. That means determinant of this a1 will be equal to, again, or let's write the determinant here. Okay, I don't have space, sorry for this. A1 will be equal to, again, how do we find determinant? We write the first term first, that is 7 upon 10. To this we multiply, we delete the row and the column in which it appears and take the determinant of the remaining elements. That means 2 2s are 4, 1 1s are 1, so 4 minus 1 is 3, so we will get here 3. Then we write minus, then this term, this one, and mentally delete the row and the column in which it appears and take determinant of the remaining elements. Okay, so this is 2 upon 3 into 2, it becomes 4 upon 3 minus this term, and with this 19 upon 30. Then we have, first is plus minus, then we have plus again, plus 1. Now we this time delete this row and this column and take determinant of the remaining elements. So what are the remaining elements? We have 2 upon 3, 2 upon 3 minus, so here 2, so it will become 15, so we have 19 upon 15. When you take the determinant, we will get the value of a1 equal to, okay, let me write it here. We will get the value of a1 is 4 upon 5, 4 upon 5. Okay, now what will be the value of q1? Q1, that means quantity supplied by firm 1 will be equal to the determinant of this new matrix, that is a1, divided by the determinant of the coefficient matrix, that will be equal to, so here we have 4 upon 5, 4 upon 5. To this we divide this 4, this will become 4 upon 5 into 1 upon 4, that means we will get 1 upon 5. That means quantity supplied by firm 1 will be equal to 1 upon 5. Same logic to find the value of q2. What will we do? We will form new matrix. Now to find the value of q2, we form a new matrix. Let's denote it by, let me see if I have the space. Okay, so to find out the value of q2, we form a new matrix. To find the value of this q2, we form a new matrix in such a way we replace the second column of the coefficient matrix with the vector of constant terms. That means our new matrix will be equal to 2 1 1. In place of 1 to 1 we have 7 upon 10, 7 upon 10, 2 upon 3, kunwa upon 3. Then we have 1 1 2, 1 1 2. Okay, then we take its determinant in this fashion. That means we will get a2 will be equal to, I have solved it, I don't know if there is any shortcut to solve this question. Okay, so a2, when we take the determinant of this matrix, we will get, I have solved it, it comes out to be 2 upon 3. Okay, that means quantity supplied by firm 2 will be equal to the determinant of this new matrix a2 divided by the determinant of coefficient matrix, that is a, which will be equal to 2 upon 3. So we got here 2 upon 3, 2 upon 3 divided by 4, it comes out to be 1 upon 6. Okay, that means quantity supplied by firm 2 will be equal to 1 upon 6. Again, so this stuff is for firm 2. Okay, now to find the output level produced by firm 3, we form new matrix. Let's denote it by, okay, why I am taking determinant first. We form a new matrix A3 in such a way Okay, to find the value of Q3, we form a new matrix in such a way we replace the third element. Simple thing. In the first, to find the Q1, we replace first element. To find the value of Q2, we replace second. To find the value of Q3, we replace the third. So we have 2 1 1, 2 1 1, 1 2 1. Then we have, in place of this, we write 7 upon 10, 2 upon 3, and 19 upon 30. Taking determinant of this, that is the determinant of A3 will be equal to, okay, using this procedure, you will get the value of A3 equal to 8 divided by 15. Then Q3 will be equal to determinant of this A3 divided by determinant of A. So we have 8 upon 15, 8 upon 15. To this we divide by this 4. So we will get 2 upon 15. Okay, that means quantity supplied by firm 3 is 2 upon 15. Now we need to find out, we know that Q is equal to Q1 plus Q2 plus Q3. That is being told us that Q is the industry output, sum of outputs of 3 firms. So Q1 is equal to, so we calculate that this is 1 upon 5 plus output produced by firm 2, 1 upon 6, 1 upon 6 plus output produced by firm 3 is 2 upon 50. Okay, that will be our Q superscript C. That means industry output under cournot Nash equilibrium. When you add up this, it will come out to be 1 upon 2. Okay, but we need to find out, see here, we got Q subscript C is equal to 1 upon 2, but we need to find out Q subscript C inverse. Okay, that means we inverse that, we write 1 upon 2 inverse. Okay, so if we have 1 upon 2 inverse, we can write it in this fashion: 1 raised power minus 1 divided by 2 raised power minus 1. We can reciprocate numerator with denominator, exponent sign will change, exponent sign will get changed, so we will get 2 upon 1, which comes out to be 2. That means industry output, that means Q inverse will be equal to 2. Okay, I hope I make myself clear.